Hello, my friend. It's me again. And today, let's look at this question. Obviously, it's another question for the operational amplifier. First of all, let's write the value on the figure. The input current is 5 microampere, and the input resistor is 33 kilo ohm. The feedback resistor is 1 kilo ohm. The load resistor is 10 kilo ohm. I think it's a good habit to write the value of the variables into the picture. Yeah, it's easier for us to do the calculation. The first question is asking us to calculate the current gain. Obviously, the current gain means output current divided by the input current. Yeah. And don't forget the four figures for the ideal operational amplifiers. The first one is input resistor is infinite. Second, the output resistor is zero, should be zero. Yeah. The third one, there's no current that can flow into the operational amplifier. And the last one is V plus equals V minus. Yeah, the potential at each terminal should be the same. All right, don't forget these four features, okay? And next, we can see this is our input current, and this current will entirely flow through the input resistor Ri. You will ask why there's no current here? Because our V plus is grounded. So the potential here is zero. So here should be zero as well. And there's no current. You see, no current can flow into the operational amplifier. So at this branch and this branch, there should be no current. All right. Okay. Now we will calculate the potential at the A point. It obviously, which is you can see here the potential is zero. So zero subtract I in multiply Ri should be the potential at A point. Okay. So VA is minus 5 micron ampere and times 33 kilo ohm, and the answer is minus 165 millivolts. All right. If we get the potential at A point, we can easily get the current IF, which is flowing from the flowing upwards, right? Which is from the ground to the point A. So IF equals 0 subtract VA divided by RF, which is 165 milli divided by 1 kilo. Okay, so which is 165 micron ampere. All right. Okay, at the point A, it is obviously that the I load equals the I input at IF. So you can call it, KCL. Okay. Yeah. Kirchhoff current law. The basis for KCL is energy conservation. All right. So we can get the value of I load, which is 5 micron plus 165 micron, which is 170 micron ampere. All right. So this is our output current. Now the gain of current is straightforward, which is IL divided by I in, which is 170 divided by 1 divided by 5, which is 34. So that's the answer for the first question. Now let's move on to the question 2. It asking us to determine, output current can cause output clipping. So what is clipping? Because as we know, the operational amplifier can amplify, the signal, which is the input voltage. Amplify means the output voltage will be or can be greater or much greater than the input voltage. All right. So if we draw this picture, we can get this thing, which is V in, V out, 0. Okay. So it should be like this. However, can we keep increasing the output voltage by some application to the input voltage? The answer is absolutely no. Because if we can get close to infinite output, this machine will be a perpetual motion machine. That's impossible. Okay. So the output voltage will be limited by these two voltage, which is VDD and minus VDD. So it should be like this. Here, you see? So the real output voltage should be looked like this. Here. Okay. At the like the red curve described. Okay. Yeah. So if our input is within this range, there will be no clipping happened in the operational amplifier. However, if our input voltage is very large and our output voltage will go to this zone or this zone, so it will be limited into the VDD and minus VDD because this phenomenon as clipping. All right. Oh, that's the basic background idea or theory. Now we can get the output voltage. Okay. The output current, as I just calculated above, which is 170 micron ampere. And the value of resistor of load, which is 10 kilo ohm. So the voltage of the load is IL times RL, which 170 micron times 10K. So the answer is 1.7 volts, which is much smaller than our threshold VDD, which is 15 volts. So the output voltage is smaller than the VDD, which means it's in the linear zone. There will be no clipping happened in these parameters. Okay. Thank you, everyone. I think you can understand this explanation. All right. Have a good day. Be safe and be happy. Bye bye.